today's topic is the third week, Autodesk Revit and BIM features. From today, we're going to use some BIM applications using representative BIM authoring tool, Autodesk Revit. Before doing some lab exercises, I like to show you some features in such BIM authoring tool, okay, as an extension from the theoretical background from the last week. So we're going to quickly review some theoretical background issues as well as some new features, focusing on two major things: solid modeling and parametric modeling in terms of CAD history. So actually we have some series of lab exercise series, but today we're gonna do lab exercise number 1 through number 5, some selective important objects making using this building, this floor, including this room, okay? So your final submission gonna be this Revit file as well as series of screenshots, okay? So that I can see your lab exercise without opening this file. But next time, we're gonna do some extensions. So at the end, the final is entire this building in BIM model and some applications, some advanced things we can do while we are working with BIM model using Revit, okay? So again, I like to show you the technical note. So we have class website, and I uploaded the PDF files for the entire lecture slide so far. So you need to get the request, this one, okay, Thursday class. And from today, you have an obligation to submit your lab exercise files, okay, through the network. This computer, this 5-dash main computer, your computer names are 5-1 through 32. So don't save your files, your submissions, my requests on your hard drive, okay? Through the network, you have to access this 5-dash main computer D drive under your name folder. I'll remind you this one in actual lab exercise hours. Anyway, you already very well known to this series of features that I put always emphasis on: managing computers and network, folders, files, and so on. So please take account this some technical strategies, okay? So also we did some Autodesk community download student access for applications, this website. So just quick review, okay? Let me skip it. And okay, let's walk through some quick review, okay, from the last week, BIM approach. I think you already know what is BIM approach and what's the difference between conventional CAD approach versus BIM approach. I would like to show you and some more emphasis using some series of examples, okay? So in architectural design, there are some quotes always say something about spaces, but actually our major subject is always, as always, space. But in CAD system or conventional approach, it's not true, because we are designing building elements, architectural objects, and some furniture, tangible objects rather than void and empty space object. Using what? Using lines or geometric shapes, okay? That's our conventional approach. But in new era, in new approach using building information modeling approach, we have to handle building objects, okay? Building elements. That's my recently developed approach regarding BIM. And I told you that is eventually same to the approach some modern architects around 100 years ago, their approach and BIM tools approach is eventually same. That's my point, okay? So this is the difference between CAD and 3D BIM approach in terms of geometric shape and their associated information. Geometric shape is just one part of building design information, okay? That's the point. And this is conventional geometry-based approach. When we are using some SketchUp, 3D Max, Rhino, such geometric tools have this kind of subcomponents of geometry, not building object, okay? But in reality, just simply think about your design process. We are thinking in this scheme, in this domain, in this model, okay? This is schema of building. And your instance, your design file, actual instance gonna be one of these schema, okay? Within this schema. So computer tools, which is supporting building design, supposed to be in this same or similar data structure, okay? That was my point. Amount of structural elements, but they are not the main, okay? Ceiling, slab, roof, beam, column, walls, they are, of course, very important design elements, but actually we are dealing with space, object, and their associated properties. So this approach totally embedded onto such design tools in this way, actually. This is IFC. I told you, you don't need to know this structure. But anyway, computer understands using this structure for a building design. That was my point. The same as human brain recognizes the building components, okay? So simply listed up in terms of engineering aspects, object and properties, okay? Object and its property, objects and its associated properties, as well as some more information, relationship, topological network, and so on. So this is data model in BIM system. In other words, Revit knows this structure, okay? How about SketchUp? SketchUp doesn't know this kind of relation or objects. SketchUp has a surface and push and pull. That's it. Just geometry. But Revit or ArchiCAD or some other types of BIM applications already have this kind of associated information. So today's lab exercise, we're going to deal with some building objects and some design tasks using building objects. And then I would like to show you why that kind of applications, BIM applications, have this information structure and how to facilitate that information system for your building design, okay? Not just simple geometric design. So let's get into Revit in terms of some design computing technology, okay? First thing we need to know is this is solid modeler, okay? Any kind of BIM application we will handle has solid modeling approach, okay? There is no surface, no points, okay? Of course, in sketch mode, we're going to deal with sketch mode too. Some points or some control vertices, but they are just virtual, okay? Not actual objects in our design. Anyway, everything is solid in Revit. You know what is solid, okay? If we define this kind of section profile, white colored area is solid fill. If we extrude this one, this is going to be this shape of solid. You know that. Even in SketchUp or 3D Max. But if we cut this out in SketchUp or 3D Max, in such surface-based 3D model, the inside always hollow, okay, empty. but this one always solid. Simply because in real world there are always solid objects. There are no empty surface-based object. So extrusion is also very fundamental method to create 3D, even in BIM. And solid blend, you know what is blend, okay? Two section profile and transform, okay? And also you know revolve, okay? Revolving using this axis. This one can be generated in this 3D form, solid form, okay? And also sweeping is, as always, very important in making 3D. Two different section profile and one pass gonna generate this kind of solid. But actually in this kind of BIM tool, there is very smart version of solid sweeping, okay? Take a look at this one. This pass and this section profile will generate this kind of realistic and some solid products. What if this one is kind of dummy, not smart? In this part, gonna be single surface, okay? And this part also surface, simply because of this sweep method, sweep approach. But this one knows this one's supposed to be solid real object. And then this one auto-turned and eventually gonna make this kind of shape. And also virtually, this one use void forms. Void forms means Boolean operation. In solid modeling, Boolean operation is very important. Boolean operation simply means plus, minus, intersection, union, okay? Even SketchUp, you can do that, or 3D Max, but they are something fake. In solid modeler, solid objects, between two solid objects, that kind of operation is valid. So we also call them void forms. So void, this box from existing box makes this one, and some other more examples are here, okay? Void forms can be revolving. A minus B, the final output, okay? All these are some features, solid modeling features in Revit or any type of BIM tools. This kind of swept solid also can be void, like this one. I like to bring your attention again in this early and handy, easy to use CAD software, homestyler.com. I introduced you this one long ago, actually, a web-based parametric modeling tool. And even mobile version of this Homestyler is available to all of you guys in public. So this homestyler.com is very easy to use, home decoration and some room design tool. And this is web interface for homestyler.com. You experienced this one before. We generated using amount of existing templates and edit, modify the wall thickness and type. At that time, when you click this wall and click right button and click information style or dimension, we can freely edit this object using associated information. So this homestyler.com wasn't simple CAD model, okay? This was BIM model. This already took advantages of building information modeling. At the time, I also told you something about that, but let's review what's actually different, okay? In this Homestyler, we can export some files, JPG image file or CAD DWG in 3D or 2D, even Revit file, okay? Why this one can export Revit file? Simply because this is BIM model, okay? This one contains information, not simple geometry. If you click this door, when you model this door, place this door, we can see its associated information. Okay, this one is exactly same to Revit's interface. Okay, so if you export that 3D geometry, that door, to CAD model and open AutoCAD, you can find out associated information gonna be all geometric. Okay, some layer information, polyline, color, and X, Y, Z coordination, Cartesian coordinate system. That's it. Okay, but this is Revit from this model. Okay, from Homestyler model exported to Revit, and this is the Revit interface. If you click this door, Revit recognizes this one is double panel door, okay? And its associated information can be found. So in Revit, it's an object. In AutoCAD, it's polyline, series of polylines, okay? That's it. So what you have done in design process, simply say, your design and concept is somewhere in your brain, okay? It's invisible to others. It's only visible to you. Even for you, it's still vague. It's still ambiguous. You have to make abstraction, okay? You have to bring your ideas to something specific. Here is something implicit, something still vague, ambiguous, and undefined. But when you do sketch, it's going to be something concrete and explicit and visible to others. So this process is abstraction, abstract process. This is simply one important part of design process, okay? What is conventional design representation? Design explicitly represented design from your head, from your brain, bubble diagram, sketch, oral presentation, and this kind of free 3D perspective generation. In industry, we need a standard, okay? Standard. So we generate this kind of symbols, okay? All these are symbols. Elevation symbol, floor plan symbol, and section symbols. Series of symbols to use your visualization, okay? So even in 1993, there were a lot of design companies and architects, designers are working for this kind of symbolic shapes, okay? By hand drawing or some technical drawings for making this kind of plans. So this is traditional communication technology in AEC/FM industry. Based upon this kind of conventional process, human invented computers and CAD systems. So they draw something by using computers, but they are still symbols, okay? Symbolic shapes, not actual objects. But when we are using BIM, when you are using Revit application, you have to recognize the difference between conventional approach so that you can maximize the meaning of building information modeling, okay? You have to know what's the difference between conventional approach and newly developed BIM approach. This is door object, and please think about what's different and what you can do more when computer understands this is door object. Okay, that's very important. If you understand and maximize the meaning of that relation and make some application, you can do something highly beyond others, someone who knows just given fundamental things. This is door object, door related properties, amount of door related objects, and which hollow opening is located on which wall, whatever. And you have to maximize the meaning. Computer doesn't know this is a door object, okay? drawing visualization is just one snapshot of this actual computational model. And another thing, this kind of Revit BIM tool only for building design, okay? 3D Max, SketchUp, Rhino, they can design jewelry, textiles, machines, cell phones, desk, monitor, any type of furniture. But when you are using this kind of building information modeling tool, no such features, okay? Only for buildings. But very concentrating on building information. So we have to maximize the merits we can take advantages of, okay? So conventional approach, focusing on geometry, let computers do what we have drawn, okay? Just for drawings. But using Revit, what we have done, entire process, okay? We have to understand this one. What if we integrate the process, not just simple visualization methods? What we can do, something what's different, actually very important. So probably you may differentiate those two different things explicitly, okay? You have to explain why, okay? So far, until last semester, in the classroom, my classroom, we handled those geometry. This is geometry term, okay? Point, line, surface, shell. And topological terms are here, vertex, edge, face, shell. And we are dealing with such geometric subcomponents for making your design, okay? Making a box first and try to make some modification, transformation to something very complicated shape. Geometry centered, some parametrics, and editing vertex, edge, polygon, using editable poly or some advanced tools in 3D Max to transform, okay, to modify this geometry to anything else. So eventually you can design anything else. Monster, tree, building, teapot, furniture, whatever, okay? But how about controllable curtain panels, building facade, interior finish, whatever, controllable. So this was our approach in geometric modeler. But when we are using Revit, we have to know this kind of approach, such as parametric modeling approach, or part-based, assembly-based, and feature-based, and constraint-based approach for design. For example, if you define this one in parametric way, using width, height, depth, and the number of panels, and then you can apply this one into any type of surface, okay? What you need to do is determining the surface geometry, and then this part gonna be assembled in automation. 10 by 10, 12 by 12, explicitly defined, not just simple geometry. We're gonna make this one, this part and this component using Autodesk Revit or Autodesk Vasari in this semester, next time. So object-oriented modeling and design in these parametric BIM tools. For editing, we need to update information. We need to update height. We need to update how many panels we need, okay? Such information, building-related information, not editable poly, okay? We don't need to take care of polygons. So parametric modeling features in Revit. This is number 2 features we need to take care of today, okay? First thing is solid modeling, And second thing is parametric modeling, okay? Parametric modeling and feature-based modeling. Feature is actually very important, geometric shape. This is one type of feature, okay? This feature can be defined in this sweeping path, and then we can create this type of 3D shape. What if you control this feature or another feature at the end? We can control the feature, and then the others gonna be auto-generated or parametrically controlled. So this type of approach in CAD system also very well known to geometric modelers, but in parametric modeling tool, fundamentally and basically, such tools take advantages of that things, okay? Let's take a look at this stair object. In Revit, you can find out this stair object, okay? This is design stair. What if you want to make this one to a couch for two, couch for 3 people, okay? In SketchUp or 3D Max, if you change the width of this chair, how about this part? Those two side widths also gonna be affected, okay? But in parametric modeler, parameter for the width of this chair gonna be one single parameter, and geometric calculation gonna be constrained in that parameter. So if you change couch for 1, 2, 3, and then this one gonna be simply updated without any unnecessary geometric changes, okay? So this is simple example of parametric modeling, but actually parametric modeling has really complicated behind the technologies and complex things. In this semester, we're not going to take care of such complicated features of parametric modeling, but at least we have to take advantages of parametric modeling features defined in BIM tools, okay, in Revit. Thanks to those features, you can take maximum advantages of such BIM tools, Revit, okay? Some new keywords we have encountered. I told you some parametrics, features, and assemblies, parts, parameters, and constraints. In Revit, we're going to see those keywords in your Revit interface, as always. So we need to take care of such series of keywords when we are dealing with solid modeling, parametric modeling, or BIM, building information modeling. I'm going to tell you again and again something about constraints or parts assemblies and some drawings, sketches, actually in lab exercise for Revit, okay? So as another review, I told you we're going to deal with this part intensively. Solid modeling, parametric modeling, building information modeling, and the bottom one always has the former ones, okay? This one contains 2D drawing. This solid modeler contains surface and geometric modeling. How about this one, parametric modeling? This one totally based on solid modeling. Everything is the basis of building information modeling, okay? So parameters, height, width, depth, very simplified parameter examples. And you're going to find out some complicated parameters in Revit interface. Thickness or some constraint to specific floors, and so on in actual Revit things. Okay, some people in this lecture got some trouble in get lecture. So I'll call a quick break, and please get back to the lecture. Okay. Again, the lecture slide. Non-uniform design of buildings. Nowadays, we can find out a lot of this kind of non-uniform designs, but actually they have some categories. Okay, some specific characteristics, such as extruders, rotors, which means some rotating shapes, and some amount of applications, subcategories, even free shapers, and twisters and tordos, and so on. But in terms of their geometry, extruded in several ways using this kind of paths, and sometimes revolving, rotors, and sometimes it can be twisted, sometimes some Boolean operation plus union, intersection, and so on. All they supposed to be parametrics, okay? Parametric modeling based design. Also feature based modeling we need, okay? We need a section profile and the paths so that you can create any type of this newly developed building types. As you see out there, Lotte Tower is one type of this non-uniform 3D shape, okay? Non-uniform design goes with always parametric design and BIM, okay? It's an inevitable trend in recent architecture, engineering, construction, and facility management industry, our domain, okay? So this is one snapshot of newly developed plan of Haeundae, Busan, okay? So something like DDP, okay? You know what's DDP at Dongdaemun? That place, Zaha Hadid design, or possibly, or could be such complicated shape, non-uniform design shape could be erected by using BIM technology, okay? So I like to show you some 3 selective case studies done by Gansam Architects and Partners using Beito Building and Korea Navy Museum and Plaza Hotel remodel project. The first example, Beito Building. This one actually located in Sinsadong, okay, Gangnam. Take a look at this building. This is just box-shaped building, okay? Nothing unique, just box-shaped building. But building owner, architects, try to make something unique features using building facade, okay? Building surface pattern. So take a look at those alternative designs, okay? Everything almost same except facade, building skin design, okay? Skin patterns. This is actual Revit model, okay? Using Revit, they designed exterior finishes, surface patterns like this. And eventually this one is the final model data and realized in this way. When you are using Revit, it has, okay, how many columns, rows we define, and one part means one component of this Cottonor system, okay? And we can simply apply that onto this surface. This surface geometry can be visualizing this part, okay? So this is final assembly. So simply you can remake by using your parametric modeling system. Simply say by using Revit, okay? We're going to deal with something like this example in the lab exercise hours. So for make this building a little bit unique compared to other conventional box-shaped buildings, we can take advantages of this kind of beam-enabled cottonwool panel design system. Okay. Next example, Republic of Korea Navy Museum. Okay, this one also partly designed by beam applications, Revit, and as you see, this building is also non-uniform building, not a simple box shape. When they designed, actually, the first sketch done by Rhino or something like that, geometric modelers, okay? And then this one can be imported into Revit. So this is Revit architecture screenshot. There are amount of control vertices, and designers try to make this form in specific modification. So eventually, the building surface can be covered with this anodizing or something metal, aluminum panels, exactly calculated by Revit beam application. Okay, if this one done by only geometric shape modelers such as SketchUp, Max, Rhino, there is no way to make some quantity takeoff for this building surface design, including interior features. Okay, so geometric shape anyway can be imported into beam application and supposed to be making some more additional information for actual construction and so on. The last example is Seoul Plaza Hotel remodeling. This is before remodel project. This one is located just in front of Seoul City Hall. Okay, you may know this building. Okay, old building, and this is the picture of under the construction. They put this screen to see some preview and actual construction ongoing formally. And this is the building exterior facade at the end of this remodel reconstruction. The major feature that I want to show you in this project is this building surface panel design. As you see, any single panel, nothing's same. In other words, they all different parametrics. Okay, something is very thicker than others. Something has some different width, height, and so on. How to control such numbers, such parameters? They all put the depth and width thickness parameters using some spreadsheet or some associated geometric control information using Revit or similar BIM software, BIM tools. And then they can make all these sub-part automatically using some fabrication methods. Okay, so eventually this one can be successfully installed, constructed in this way. But anyway, what if this one is just a Max file, CAD file? Anyone who's in charge of making those parts should be working very hard, okay, very time consuming. Even if they did in that way, probably a lot of mistakes found, okay, because of different geometry, different dimension, different thickness. Something can be installed. So this one was remodel project. Even by conducting this kind of remodel project, also supported by BIM technologies such as Revit and so on. Next thing is kind of Revit specific, focusing on building components. Okay, this is an early pilot project using BIM, using Revit. This is Raleigh Durham building, training building. Just simple rectangle shape building in US. Let's take a look at this one. This is general floor plan of this building. Okay, based upon this plan, exterior walls can be modeled like this, and some structural elements, including columns and some foundation objects. and some structural more elements for the second floor, and some beams sustaining structure of this building. And this one shows you some interior walls and some elements for the first floor, and some mechanical system, mechanical, electrical, and plumbing system for running this building, okay? And second floor, interior partitions, interior finish walls, doors, amount of interior window objects, and so on. How about this? Trusses for sustaining roof object, and the entire roof objects can be visualized in this way. This one not for just fancy visualization. This one only shows you building subcomponents can be categorized and grouped by same or similar related objects. By using this kind of BIM tool, I told you Revit understands which one is roof, which one is windows, which one is truss structure for sustaining roof component, and so on. So you can simply filter the object in your building design, building model. Sometimes we are focusing on just interior finish, design visualization components, but those structural or some interior related architectural components are also very important for actualize this building, okay? So if they are all just geometry, we have to put some layer information or some geometry grouping features for making this kind of visualization. But by using BIM tools, fundamentally, basically, we can take advantages of this kind of object filtering, simply because Revit understands building elements, okay? We're gonna deal with actually in Revit interface in this lab exercise. As another quick review, this is Revit, and we model, this is another review from the last week, okay? In this interface, we can find out building elements, okay? Of course, there are some annotation, symbol related things, such as line or some annotation, dimension, but all they are totally embedded in this BIM system, not just separate geometry. So we are not going to deal with points, lines, surfaces, polygons, and so on. We're going to deal with actual objects based on amount of predefined object families. The term family here is kind of Revit specific term, family, but simply general term is library, okay? Object library. What if you want to try to make very specialized wall object? You have to define your own wall object. But thankfully, there are amount of wall library. Most of wall library pre-installed in Revit, hundreds of wall objects. And you can put some different dimension. You can edit. But what if you want to create your own wall? You have to open family editor in Revit. And you have to create your own family. In other words, you have to create your own wall library, okay? And load this one to your building project. And then you can reuse that library. So simply think about if you are working in world famous architect firms such as HOK, SOM. They have their own library, okay? They have amount of wall library, window library, components, roof, ceiling, structural elements, and so on. And someone's in charge of handling such interior objects. They are in charge of making them and loading into the project. How about furniture? There are too many furniture in the world. IKEA possibly provide Revit files, family files. How about Herman Miller, world famous furniture company, Steelcase, and so on. Such company website provides BIM model, okay? So that people can use their furniture into BIM tools, Revit model. It's totally different from distributing SketchUp file. That's only for visualization. But what if they provide Herman Miller specific furniture system into BIM model? It has price tag, okay, and quantity information. What they need to do is download the file and load into project and make some layouts for entire building as their furniture system. And then simply they calculate how many partitions, how many desks, how many Herman Miller chairs they need, and they can simply calculate the cost, okay? Rest of the thing is negotiation. We're gonna use your products and get some bill in good price, something like that, okay? Anyway, this is next week's final submission, yours. But today, we're gonna make 5th floor, this floor, including this room, okay? I'll let you know, and you're gonna find out you can finish this up until end of this class today. Very easy and faster than Max or some other tools. So this is first screen. You need to open project using new based upon template, okay? I'll let you know what's difference in project file, template file, library file, and so on. And this is family editor. In this semester, we're not going to deal with this family editor. We're going to deal with this project editor as a Revit file. But you have to remind that there are amount of system family or custom family. System family means predefined objects. We're going to use predefined objects mostly, but you can download or you can create your own. They are custom family, okay? Something from external of this Revit application. So in this interface, we're going to deal with these objects. And take a look at this. You have to see this page if your Revit doesn't have library, or if you are missing the location of template file, library file. Take a look at this folder structure. See program data, Autodesk Revit, Revit 2015, and templates or libraries, okay? This single folder has around 2.5 gigabytes. If you install Korea standard, international Korea standard, and US metric, just for 3. If you install worldwide libraries, this one gonna be 60 gigabytes, okay? But now I checked yesterday, around 2, 3, around 5 gigabytes. So we can take advantages of those predefined objects. So we're gonna use this template, US metric template, and amount of libraries on the US metric or on the Korea standard, okay? On the Korea standard, you can find out objects names are in Korean. 벽체, 창문, 보, something like that, okay? But that's fine, but I recommend you to use US metric first. If you open US imperial, and then you cannot see metric dimension, everything in inch or feet, so it's not easy to measure actual scale, so use metric, that's my recommendation. So this is ribbon interface of Microsoft, looking very simple, but actually complicate. If you click wall, you can find out amount of wall specific interface. If you click door, this is place door related interface. This one gonna be popping up when you click something, okay? So interface is kind of interactive. If you click some roof related icon, and then you can see roof related sub interface. So load family, place model, and so on. There is another important concept, sketch mode. I'll let you know in actual model. Interface issue, always complex to novice users, but I always put emphasis on interface is just interface. If we understand the behind technologies, just get used to be using those interface, and then you can use anything we need. This is property window. We're going to use this one too. And project browser. And I like to show you this one and explain a little bit about these key features. First thing, by using Revit, still amount of geometric modelers are available. What if you want to use SketchUp based on your Revit model for your design studio? Simply exporting the file in DWG, DWF, or FBX, or a lot more file formats. FBX, it's good for Autodesk material. Your material is going to be all contained in FBX format. When you open FBX file in 3D Max, that is one of our lab exercises, okay, later. From Revit to 3D Max, and then simply visualize your objects. So geometry file supportive. One important thing is when you open floor plan and export into DWG, that's going to be 2D CAD file. But in 3D view mode and you export to DWG, that's going to be 3D CAD file, something interactive. What if you want to export everything in Revit? What if you want to create something in Revit, and if you want to open that Revit file in ArchiCAD, something different BIM tool? In that case, we can use IFC format, okay? This one contains everything: geometry, information, building information, relation, everything. So far, actually, technically not 100%, but almost 100%. You can reuse information. Nothing is missing, okay, technically. But in reality, amount of unnecessary and unexpected problems. That is why someone who knows design computing, someone who knows BIM, has more opportunities in job industry or something else. That's very important thing, okay? And this is space object oriented building modeling. There is mass object, space object. In Revit, the term space is room, okay? If you model this room, you have to place room object. And then you can do a lot more applications based on that room object. We're going to deal with this one, today's lab exercise. And amount of auto-generated 2D plans. What if you want to generate elevation, sections, formalized symbols in architecture? Revit gonna generate automatically. What you need to do is doing something, modeling something in floor plan view mode, any one of them, and then all others gonna be auto-generated, okay? If you need some annotation, place them, that's it. And modeling building objects and geometry in advanced features. Parametric modeling, solid modeling, and some more even advanced features already auto-loaded in Revit. So what we need to do is just try it, just use it. What you are using Revit means you are using advanced features behind the technologies automatically. We don't need to take care of them. What we need to do is just take maximum advantages of such features, okay? If you know programming, .NET, Microsoft Visual, C# or something else, you can make some additional applications on top of Revit or BIM tools using their API. Some of my junior students, my friends working in HOK or some other famous companies in the US or even in Korea, Gary Technology, one of their works is simply programming on top of Revit for their customized design, okay? Nowadays, people use Revit for actual projects. They need some more features, so they program what they need. you think you are not programmers, but if you can do program based upon your architecture background, same, more job opportunities in higher salary in big companies. I know this is not good for recording or some actual official class, but that's reality. Okay, very important. And also supporting collaborative working environment. What if you three for one project, one building project? So far, separate CAD model, separate 3D Max file, but by using Revit, there is centralized Revit model. We can use one model, auto update, auto transaction, history checking, even by cloud-based, cloud computing-based things. Actually, in big company, they use centralized Revit model through network, through internet. Also, this one is good for visualization too. This one has renderers or export geometry to other visualization tools and so on. So mass object and auto generation of building components and room object. Take a look at this auto generated room boundary. We're going to make this one and demonstrate to you today. And fundamental render scene, another rendering scene, and interoperability example by using Revit and 3D Max. Geometry by Revit and lights and more effective rendering features in 3D Max. And some Revit rendering examples that I can show you. Okay, let's for the lab exercise, we need to take a look at some object and some Revit features. Okay, it's time to lab exercise. Okay.